We have car X with a mass of 1,000 kilograms and a speed of 10 meters per second traveling around a circular track with a radius of 100 meters. That's happening on the left. There's a flag in the center of the track, and points A and B are on opposite sides of the track as shown. Identical car Y travels on a straight road at a speed of 10 meters per second. There is a flag that is 100 meters from the straight road, and point C is on the road at the point closest to the flag. Point D, way over here, is 200 meters down the road from point C. What is the angular momentum taken about the flagpole of car X when it is at point A? Car X, we're on the circle, point A. So we know the angular momentum equals mvr sine theta, where the angle theta is the difference between the velocity and the distance from the pivot point. So that distance is going to be 100 meters there, right? So that is the radius of this circle. Then we have the velocity acting in this direction. It's tangent to the circle. And that velocity we know to be 10 meters per second. And when we plug all of this in, the mass 1,000, the velocity is 10, and the radius is 100. The angle between velocity and the radius, look at that, is 90. So sine of 90 we already know is 1, so we don't really care about that. So in this instance, our angular momentum is going to be equal to 1 million. And what about those units? Kilograms times meters squared per second. All right, so what about car X when it's at point B? When it's at point B, we are now 100 meters from the flag. Our velocity is going to go this direction, and the angle between these two are the same. Our mass hasn't changed, so why would our angular momentum change? It hasn't. L is still going to be 1 million kilogram, not joules, times meters squared per second. Car Y. Car Y, the straight line. When it's at point C. All right, so when we're at point C, our velocity is going to be this way, 10 meters per second. This 100 meters from the flag is going to be the R. So when we put in L equals mvr, what's the mass of this thing? Y, 1,000. Okay, so it's going to be 1,000 times V times R times sine theta. These two are perpendicular to each other, so that's going to be a 1. So we get L equals, you guessed it, 1 million kilograms times meters squared per second. What about at point D? All right, so now we're at point D. We have this big, long distance. We know our velocity is going to be going in this way. It's going to be 10 meters per second. This is 200 here, and this is 100. So what is the distance from the flag? Okay, so to do that, remember our equation is L equals mvr sine theta. And that sine theta, if it is 90, then it's going to be just 1. So just like we did when we talked about torque, we can make this the perpendicular distance from that 10. And when we do that, because we only care about the perpendicular component of R, we only care about this part right here, we're going to get that same 1 million kilograms times meters squared per second.